3D printing is not new to General Motors. GM has been prototyping with 3D printing for 30 plus years. We've shifted our focus a little bit over the last few years with new investments in three key areas: functional prototypes with early vehicle builds, manufacturing tools with our production sites, and production parts themselves.
We at GM like to be at the forefront of technology deployment and evolution. So our mission is truly be the leader for additive manufacturing and value-added applications in the automotive space.
We have operations globally, and we work with a network of contacts and engineers to tackle 3D printing challenges and production challenges across the globe. Our newest site, the Additive Industrialization Center, is focused on bringing additive manufacturing to a production environment and supporting General Motors' global 3D printing operations from a central hub location.
There's a lot of promise for what additive manufacturing can do for you in the end use case. That area of functional prototyping, as you're developing the vehicle, there's many places where you can accelerate the design efforts or save money by printing your parts. And then you jump over to how you actually build the car in our manufacturing assembly plants and using tools or assembly aids. And then finally, the production parts.
3D printing has allowed us to cut significant weeks and months out of production of components and tools, and allows us to get our vehicles to the market quicker.
Every day, every week, there's something new out there, and we've only scratched the surface in terms of applications.
Traditionally, when we're making pre-production vehicles or prototype parts, it's very long lead times, tooling is very expensive, and so 3D printing allows us to achieve the same goals, do that faster, and do it cheaper. And so one example of where we've implemented this functional prototyping is on our newest C8 Corvette program, where we actually printed brake cooling ducts on the vehicle itself. We're able to make design changes at no cost, save 9 weeks in development time, and 64% cost savings on that program. And this is just one example of the prototypes that we've implemented across our programs.
In today's industry, we're not just making components for cars. We're actually looking at making manufacturing tooling and trying to change the way cars are made. Tools that we have done successfully include handheld tools, which an operator can use on the plant floor. We've also had successes with automation tools, which are placed on robots. Another place is rapid response tools, where an operator is visualizing if they could just have a tool which would be customized just for the job. They are able to communicate that back to us. This turnaround time could be as short as 24 hours to 48 hours. Where traditional tools may have been 10 to 14 pounds, our handheld tools, which are 3D printed, could be as little as 2 to 3 pounds. At our GM Arlington assembly plant, we found that we were able to reduce the lead time by 10 to 12 weeks.
We're really excited about the first few production parts we're going to have as well. On the upcoming V-Series Cadillac Blackwing,
we have 2 HVAC ducts that are made out of plastic. We also have 1 metal component on the vehicle, which is an electrical harness bracket.
We know our customers are excited about a performance manual sedan, and the additive manufacturing really helped bring it to the market. The manual shift knob emblem is going to be a unique 3D printed design only found on that vehicle and only possible with additive manufacturing.
The durability of the 3D printed parts has been proven in the motorsports environment. We have over 13,000 miles on the Corvette C8Rs from the 2020 season with over 75 3D printed components. Not one of them failed. So surviving tough races like the 12 hours of Sebring and the 24 hours of Daytona shows that these parts are up to the demands of the most extreme environments in the world. The aluminum oil tank and inlet took 8 different components, consolidated them down into 2. In the process, we dramatically improved reliability and we eliminated 14 welds.
It allows for creativity and engineering to come together in a way that we have not seen before. The outcome itself is revolutionizing how we build cars.
There's so much that we can do with this technology today, and I truly see it proliferating throughout our product portfolio, throughout our manufacturing tools portfolio. We want additive manufacturing to be that mainstream to General Motors engineering and manufacturing.